We know that this is a product. So when I differentiate y, I have to write dy over dx multiplied by cosine x plus y times cosine x prime, which is negative sine x. And then on the right-hand side, I don't have any product or quotient or anything like that. I will differentiate x squared as 2x. But I have a power now. So it's 3 y squared dy over dx. So that's my next step to finish up this section. So I'll come back to it. So from here, I see that dy over dx is present in two different terms. They have to be on the same side. So I have cosine x, but minus 3y squared and dy over dx. And these two terms have to be on the same side. This is a negative term, so when I move it to the other side, I get positive y sine x. So finally, I get dy over dx as the ratio between 2x plus y sine x and cosine x minus 3y squared. All I need to do now, the only thing I need to do is evaluate it at 0, 1. I'm sorry, 0, negative 1. So that's all I'm going to do when x is 0 and y is negative 1. X is 0, this is 0. X is 0, this is 0. 0 plus 0. Cosine 0 is 1. Negative 1 squared is 1. 1 times negative 3 is negative 3. So 1 minus 3. Who cares? 0 over a number, so the slope is 0. Any questions on this? You are not asked to find the equation of the tangent line, just to find the slope of the tangent line at that point. Any questions on this? Okay, so the inverse trig functions, I only, as I mentioned, and I promised, just these three, because these three are very important. So remember the other notation for this, which is a little bit confusing, is sine inverse. Don't say sine to negative 1. It's not 1 over sine. So this name is, the name of this expression is sine inverse, not sine to negative 1. The same thing here is cosine inverse and tangent inverse. I don't like this notation. I prefer this one. It's also easier for me to type than putting in the power. So sine inverse, cosine inverse, tangent inverse. Of course, there are 6 trig functions, inverse trig functions, and 6 inverses. So we're only going to talk about the derivatives of these 3. I think you're going to find easy to remember. Sine inverse prime is 1 over the square root of 1 minus x squared. Cosine inverse prime is the same thing, but with minus in front. And the last one is even nicer. Tangent inverse prime is 1 over 1 plus x squared. Just these 3 that I want you to remember. Because if you have to look for each and every little piece of information, then it becomes harder and harder at some point in time. So these have to be memorized, please. Now, let's say we have, oops, that's 8. Let's say we have arc cosine of the square root of 1 plus x squared. You can say, but this is not this. We don't have x here. It's a function. Yes, but we know how to handle this. So first of all, what do I have to write? I'm differentiating arc cosine or cosine inverse. What should the initial steps, what will they be? Give it a shot. It's okay if you're wrong, please.
So you write -1. Divided by root 1 minus x squared.
Now I have to stop.
Oh.
You're correct. Everything you said is perfect. This squared, because this is not x. So let's square this. What do I write?
One plus x squared.
Very good, of course. Times the inner function prime. Can anyone differentiate this function for us?
So 1 over 2 square root 1 plus x squared.
Times the inner function prime.
2x.
That's it. Awesome. Great job. Yes, I'm going to simplify it a little bit. The 2 from the top with the 2 from the denominator. And let's see if we can condense it. So negative 1 over. So here I have 1 minus x squared. 1 minus 1 goes away. And then times x over the square root of 1 plus x squared. Yes, it can be written as x over the square root of negative x squared, the square root of 1 plus x squared. Now, obviously, I made up this problem. We're going to look at examples in a minute from the book. And I have a problem with my example because the square root of negative x squared. So I have to go back and make an adjustment because I can't have that. I made it up without thinking. So I'm going to change this into minus. So I don't get into that situation with a negative sign under the square root. So now it's legit. 1 minus 1 goes away, but negative 1 times negative x squared will be positive x squared. And now it's okay. And I can even take the square from this and simplify it, assuming all conditions are fulfilled. So negative in front, and then x, the square root of 1 plus x squared, and these two go away, and I can further simplify it. So what all this is illustrating is what we already knew. If we know the formula, and if we have a function, we use the formula, but then we never forget to times the inner function prime. That's all I was trying to illustrate. And now I will let you choose a problem, assuming I'm not logged out of this as well. Okay, so we are ready to choose any problems from here. Here they are, 63 through 78. Sine inverse, secant inverse, I don't care for secant. Tangent inverse is okay. Tangent inverse is okay. Arc cosine, arc sine is okay. Arc tangent is okay. Cotangent inverse we don't need. I can show you the formulas. They're fine. I'm happy with those three functions. Okay, I will choose 70. Or you want to choose. It's fine. Whatever you want to choose. Anyone would like
70.
70. We like 70. Perfect. So g of t equals natural log of arc tangent t to the fourth. Perfect. What is the outermost function?
Log.
The outermost function is?
Natural log.
And then the next one? Anyone?
Tan inverse.
Exactly. And then the last one?
T to the fourth.
That's it. So let's differentiate natural log.
1 over.
1 over whatever. times the inner function prime. How do I differentiate arctangent?
1 over 1 plus x squared.
Yes, but not x squared, whatever I have here.
T. Yeah.
Good. Times the inner function prime.
4t to the third power.
That's it. No one can further simplify it, but I can slightly condense it, and I don't have enough room here. I'm going to move on to the next page. So this is 4t to the third over 1 plus t to the 8th times arc tangent t to the 4th. That's how we deal with this, with the inverse trig functions, only for arcsine, arccosine, and arctangent. Do we need more examples? What about 67? Is 67 okay, or you want to pick something else?
Just do it.
Okay, 67. We have y equals tangent inverse of x everything squared. So please remember, when you see tangent inverse, I don't want you to say, oh, I bring -1 down and I subtract 1 from the, please be careful. Tangent inverse is a function. It doesn't have a power. Now it does. It has power too. Okay, so we want to find y prime. Which one is the inner, which one is the outer? Because we have to start with the outer.
The power.
Yes, so let's differentiate. Awesome.
2.
Yes. Arctangent or tangent inverse x, good, times the inner function prime.
1 over
Yep.
1 plus.
That's it.
X.
That's it. And if you want to condense it, this is not an equation. I can continue to the side. I'm not solving an equation, so I can continue with equals, 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 equals. So this is 2 tangent inverse over 1 plus x squared. Perfect. Okay, we can go back if we can, when you find something by Monday in WebAssign from here, we can work on any other problems. So let's continue with 3.7. So we have left 3.7, 3.8 is not part of this course, 3.9 and 3.10. So hopefully we can at least finish 3.7 tonight and start 3.10, and then Monday to finish these two. Okay, so 3.7, here we're just going to look at different applications. Other, it's real life or word applications. Of differentiation, of course. Okay, so I'm just going to open directly. There is nothing that I need to explain. We just have to practice. Okay, so we're just going to look at simple applications, mainly physics and some other sciences, but the biology, the economics, and chemistry, they will be discussed in those specific disciplines, right? In chemistry, when you take a chemistry application, they will talk about, but what you see here, it's applicable in all these, okay? Good. So we're going to look at this set of problems here. It's a very important set of problems, but after we practice a little bit with easier problems. So let's say, okay, so let's start with problem 11. We discussed these situations before. You'll see in a moment. If a rock is thrown vertically upward from the surface of Mars, it doesn't matter where, with velocity 15 meters per second, its height after t seconds, so we are given a function h of t, 15t minus 1.86 t squared. What is the velocity of the rock after 2 seconds? So velocity after 2 seconds. And part B, what is the velocity of the rock when its height is 25 meters on the way up and on the way down? Distance, h of t equals 25 meters. So we have meters per second, the velocity. Okay, perfect. So first of all, we are given the distance formula, and we're asked to find the velocity at 2. What do we need to find first?